Hey guys, welcome back everybody. Hope you all are doing great. Guys, today in this video I am going to troubleshoot BGP routing protocol, and this is my scenario in front of you. As you can see in my scenario there are three routers, R1, R2 and R3. I am running BGP AS number 100 on R1, 200 on R2 and again 100 on R3. You can say R1 and R3 are customer routers and R2 is the service provider router, right? Like R1 and R3 are C routers of same customer. Let's say router 1 is C router at side 1 and router 3 is C router at side 2, right, at any another side. So both are C router and both C routers are connected with provider router, service provider routers. After configuring the BGP, these two PCs are not able to communicate with each other. As you can see, router 1 is connected with one LAN, right, where I have one PC, and the subnet inside in the LAN is 10.1.1.0/24, and LAN connected to router number 3 where I am running subnet 20.1.1.0/24. IP address on PC1 is 10.1, IP address on PC2 is 20.1. And you can see the issue over here is this one. After configuring BGP on all routers R1, R2, R3, PC1 and PC2 are not able to communicate with each other. So as a network engineer, we are going to troubleshoot it. And guys, BGP is an very important routing protocol for all network engineers, because nowadays we are using it in the production network, in the real-time network. So you will be troubleshooting these types of issues many times. So if you are a network engineer or if you are planning to become a network engineer, make sure you will watch this video till the end. If you know the issue, like what can be the issue, right, according to you, if these two PCs are not able to communicate with each other, then think what can be the issue. And if BGP is running fine, BGP neighborship is fine between all the routers, right, then why these PCs are not able to communicate with each other? What can be the issue? So if you have any possible reason, then please share that scenario in the comment section. I will check it. And in case if you don't know what can be the reason, then watch this video till the end. Now without wasting our time, let's begin. First of all, we are going to verify the issue from PC1. I am going to ping PC2 to check really these two PCs are not able to communicate. And here you can see I have CLI access of all the devices. This is CLI access of R1, and here I can run command show IP BGP summary, and you can see on R1 we have one BGP neighbor 12.1.1.2, which is the IP address of router 2. Between router 1 and router 2, I am running this subnet 12.1.1.0/24. IP on router 1 fast Ethernet 0/0 is 12.1, and IP on router 2 fast Ethernet 0/0 is 12.2. And subnet between router 2 and router 3 is 23.1.1.0/24. 23.2 is the IP address on router 2 F1/0, and 23.3 is the IP address on R3 F1/0. So this is the IP address of router 2 fast Ethernet 0/0, right? So neighbor IP address is 12.2. This is version, AS number is 200. That is correct, fine. Message sent 23, receive message also 20, send message 24 and receive message is 23 from this particular neighbor, right? And this neighbor is up from around 18 minutes, okay, and it have received 0 prefix from this neighbor. But router 1 should receive this 20 prefix from this neighbor, right, because R3 is going to advertise 20 submit to R2, and then R1 will advertise it to, sorry, R2 will advertise it to R1, right? In the same way, R1 will advertise this 10 submit, this submit to router number 2, and then router 2 will advertise it to router number 3. But on router number 1, we are able to see receive prefix is 0 from this particular neighbor. On router number 2, we can verify the BGP neighborship, so IP BGP summary, and here you can see router 2 have two BGP peer, one with 12.1.1.1, which is the IP address of router 1, right, and one is 23.1.1.3, and this router 2 is receiving one prefix from both neighbor, right, one prefix from 12.1 also from router number 1 also, and one prefix from 23.3 means router number 3 also, right? Definitely router 1 is advertising 10 subnet 10.1.1.0 and router 3 is advertising 20.1.1.0, but router 2 is not advertising this subnet to router number 1. Now again I am asking you same question. If you know the reason, like because this is hints, router 2 have received route from their both neighbor but it is not advertising to other neighbor, or maybe it is advertising or other routers are not receiving, right? So tell me what can be the reason if you know. Okay, if you don't know, no problem, we are going to discuss it. So on router number 2 also we have verified the neighborship and neighborship is fine. Router 2 is receiving one subnet from both neighbor. Now let me take you to R3. On R3, so IP BGP summary. On router number 3 also you can see we have BGP neighborship with router number 2 23.1.1.32, which is the IP address of router 2, and receive prefix from this particular neighbor is 0. So router 3 is also not receiving any prefix from this neighbor. Now here I have access of PC1 on this PC, so IP all, you can see IP is already configured 10.1.1.1/24 and gateway IP address is 10.1.1.100. 10.100 is the gateway IP address of PC1, right? In the same way on PC2, so IP all, here IP is 20.1 20.1.1.1 and gateway IP address is 20.1.1.100. Now from PC1 I am going to ping my gateway first. Like gateway means the IP address which is running on router. So gateway IP address is 10.100 ping 10.1.1.100, and you can see I am able to ping my gateway IP address. Now let me try to ping PC2 ping 20.1.1.1, and you can see I am not able to ping and I am getting which error? Destination host unreachable. That means my default gateway don't have routes for this destination 20.1.1.1, right? Even you can here verify the ARP table, like this machine should be able to resolve MAC address of default gateway, fine. So guys, see, when I am pinging 20.1 from PC1, 20.1 is PC2, what will happen? This PC1 will generate one ICMP echo request message, ICMP echo request. In that echo request, source IP address is going to be 10.1.1.1 PC1 IP address, destination IP will be 20.1.1.1 PC2 IP address. Source MAC will be the MAC address of PC and destination MAC will be the MAC address of default gateway, means MAC address of fast Ethernet 1/0 of router 1, right, will be the destination MAC. After that, this PC will forward it to switch will forward it to router. When router will receive it, router will first check layer 2 information. At layer 2 it will check the destination MAC address, destination MAC will match, then it will check layer 3 information. In layer 3 it will check the destination IP address, destination IP address is 20.1.1.1. 20.1.1.1 is not router 1, so router 1 is going to check their routing table, right? So R1 will look up their routing table, so IP route and 20.1.1.1, or you can say it will check the SAP table. In SAP table also entry will be not available, so IP SAP 20.1.1.1. you can see no route in the SAP table, even no route in the routing table. So R1 don't have route for 20 subnet, so what will happen? R1 will drop the traffic. In the same way, when PC2 will ping, let me first ping their gateway 20.1.1.100, and you can see I'm able to ping the gateway. Now let me ping PC1 ping 10.1.1.1. so again same error I am getting, destination host unreachable, because when you will ping PC1 from PC2, again PC2 will generate ICMP echo request message. Source IP is going to be 20.1 and destination IP is going to be 10.1. It will forward to switch will forward it to router 3. Router 3 will compare it with destination IP address with routing table. So in the routing table of R3, so IP route and 10.1.1.1, you can see network not in table, so IP SAF 10.1.1.1. It is not available in the SAP table also. Done. Now we need to troubleshoot the BGP between R1 and R3, like why router 1 is not receiving the route. So guys, let's understand. See, first of all, on R1 we are advertising 10 subnet in BGP. So IP BGP. In the BGP table you can see router 1 have installed this subnet 10.1.1.0/24. Next hop IP address is 0.0.0 because it is self-advertised prefix. Weight value is this one default, and these are the metric components, leave it. And this prefix is valid as well as best. So router 1 will advertise it to their neighbor, right, to R2. So on R2, so IP BGP. On R2 also you can see in BGP table we are able to find this subnet 10.1.1.0/24. Next hop IP address is router 1 IP address 12.1.1.1. These are the attributes, and this prefix is valid as well as best. So router 2 is going to install it in the routing table. So IP route BGP, yes, this router have installed this prefix 10.1.1.0/24 in the routing table with distance 20 because it is receiving from eBGP, right? Like if you want to verify the neighbor type, simply you can run command so IP BGP and then neighbor. So here you can see both neighbors are external link, right? eBGP, and for eBGP AD value is 20. For iBGP AD value of BGP is 200, right? So in the BGP table here we have 10 subnet. Now question is, will R2 advertise it to R3? Definitely yes, right? Because router 2 have two neighbor. So what happened guys here? Router 1 have generated one update message BGP update message. In that update message it will include this subnet 10.1.1.0/24 with some attributes, and then source IP and destination IP, right? Destination IP will be the IP address of neighbor. Source IP 12.1.1.1, destination IP in the IP header 12.1.1.2. you have defined it, your neighbor is 12.2. Done. So it will forward it to router number 2. Question is, in the attribute there is one attribute called ES path, right? So whenever router advertise prefixes to their eBGP neighbor, then router always include ES path. So it will advertise this prefix with ES path ES 100, their own ES number, right? When router 2 will receive it, router 2 will install this prefix in their BGP table, right? If next hop is reachable, then it will also install in routing table, right? And then if there is any another neighbor, then it will advertise to their another neighbor also. So IP BGP summary, yes, it is receiving this subnet, this update message from this neighbor 12.1. Definitely it will advertise to another neighbor 23.1.1.3. Now which type of neighbor it is? This one is eBGP neighbor. So whenever router advertise prefixes to their eBGP neighbor, it will include the ES path. So with the help of this update message, router will install this prefix in their BGP table as well as in their routing table because prefix is valid as well as best. After that, router 2 is going to advertise it to router number 3. And whenever router will advertise to their eBGP, then it will also modify the next hop, right? So guys, first it will include the ES number 200, and then destination IP in the IP header is going to be 23.1.1.3, and source IP address is going to be source IP 23.1.1.2. It will advertise to router number 3, right? If you want to check router 2 is advertising it to router number 3 or not, because see, we are very clear that router 3 is not receiving it. So IP BGP summary, here you can see receive prefix from this neighbor is 0, and even you can check the BGP table. So IP BGP, in BGP table we have only 20 subnet, which is the directly connected, which we are advertising here, right? Self advertised. Next hop 0.0.0. On R3 we have only 20 subnet in BGP table, right? So there are two questions. One, is router 2 advertising 10 subnet to router number 3? Second, is router 3 not accepting the update message from router number 2, right? What is the reason? Two things can be happened here. Either R2 is not advertising the prefixes, or R3 is not receiving the accepting the prefixes, right? So guys, you know the loop avoidance mechanism in case of eBGP is do not accept the prefix where your on AS number is included, right? So as you can see in this update message, when router 3 will receive this update message, it will see their on AS number, which is 100, right? AS number on router 3 is 100, right? And same AS number is coming in update message also. That means this is loop. Router 3 will not accept it, right? To verify it, what we can do on router number 2, we can use one command. We can use command show IP BGP neighbor, and the neighbor IP address 23.1.1.3, and here I can say show me the advertised route, which route you are advertising to this neighbor. So you can see R2 is advertising both subnet 10.1.1.0/24 and 20.1.1.0/24 to this neighbor 23.1.1.3, right? So R2 is advertising, but on R3 we are not able to see the prefix. We have only 10. The reason? ES path. The reason, guys, ES path. So here what we have to do? Here we have to tell to router that allow your on AS number in the update message, right? By default, BGP does not allow their on AS number in the update message. If BGP will see their on AS number in the update message, it will discard it, right? But you can configure it. You can tell to router to accept update message with your on AS number also. For that, on R3 I can say router BGP AS number 100, and I am saying your neighbor 23.1.1.2, because we know that loop cannot form here in this scenario, right? Like the topology is not in circle, so loop will not form. So I can say neighbor, this neighbor 23.1.1.2. What I am saying, whenever you will receive from update from this neighbor, allow your on AS number. So allow AS in, allow AS in. After running this command here, if you will check so IP BGP, so now you can see we have this subnet 10.1.1.0/24 in the BGP table, and this prefix is valid as well as best because next hop is reachable, right? So R3 is going to install it in routing table, so IP route BGP, right? So you can see now in the BGP table, BGP routing table of R3, we are able to see 10 subnet. In the same thing, we need to configure on R1 for 20 subnet, right? So let me take you to R1, and here if I will show you the output of so IP BGP neighbor 12.1.1.2 and received route, so what prefixes it is receiving from the neighbor router BGP as number 100 and neighbor 12.1.1.2 and soft reconfiguration inbound, right? Now we can use that command. So see, it receive prefix. What command I used here? So IP BGP neighbor 12.2 and received route. Show me the route which you are receiving from this neighbor, and total number of prefixes is 0, right? It is not receiving any route. The reason same, their on AS number, because when R3 will generate update message, BGP update message, in the update message it will include ES number for 20.1.1.0/24. ES number will be 100, right? It will be router 3 will forward it to router 2. When router 2 will advertise it to other neighbor, to router 1, it will also include their AS number because it is eBGP neighbor, so 200. And when router 1 will accept it, it will see their on AS number, so it will discard it, right? So simply I can configure allow AS in command on router number 3 also. say router BGP AS number 100 and I am saying neighbor 12.1.1.2 allow AS in. And now same command I am going to use here, and this time you can see it is receiving this subnet 20.1.1.0/24. R3 is receiving this subnet 10 and R1 is receiving 20, right? Now BGP table, so BGP routing table, so IP route BGP. So guys, here we have now 20 subnet, and on R3, so IP route BGP, here we have 10 subnet, right? So now what will happen when PC1 will ping to PC2? Again, it will generate the ICMP traffic, it will forward to router. When router will receive the traffic, it will compare destination IP address with routing table. Again, router 1 is going to check SAP table, so IP SAP, and then 20.1.1.1. This time you can see route is available, right? For this subnet, next hop IP address is 12.2 and exit interface is F0/0, right? So router 1 is going to resolve MAC address of 12.2, so IP ARP, it will resolve MAC address of 12.2, this one, and then it will forward traffic to router number 2. Router 2 will also compare destination with routing table, so IP SAP 20.1.1.1. so next hop IP is 23.3 and exit interface is F1/0, so IP ARP MAC address is available in the ARP table, so PC2 can forward it to, router 2 can forward it to router 3. When router 3 will receive it, router 3 is also going to check their SAP table, so IP SAP and 20.1.1.1. It will get to know that this network is attached, means connected, directly connected network, on which interface? On F0/0. So router 3 is going to resolve MAC address of PC2 directly, means 20.1, so IP ARP MAC address of 20.1, here it is, and it will forward to PC2. Now PC2 will generate reply. PC2 will generate reply. This is the reply message. Reply. In the reply, source IP 20.1, PC2 IP address, destination IP 10.1. It will forward to router 3. Router 3 is going to compare destination IP address with routing table, so IP SAP and 10.1.1.1. Yes, route is there, exit interface is this one, next up is 23.2. It will forward to router 2. Router 2 will compare with routing table, so IP SAP and 10.1.1.1. yes, entry is there, it will forward to router 1 and router 1 will forward it to PC. So now we can verify the connectivity from PC1. I am going to ping PC2 now, and this time I am expecting reply message, and yes, you can see here I am getting reply from PC2. So guys, this was a small troubleshooting of BGP, border gateway protocol. In real time, sometimes you will face these types of issues, and many more possibilities, reasons are there for communication not happening between PC1 and PC2. This is one common reason. After enabling BGP, you need to run extra command here in this scenario, allow AS in, that is the extra command. Okay, and guys, if you want to learn these all things, this protocol, BGP protocol and other routing protocol, switching protocol, SDN network in detail, then we are launching our fresh courses of networking like CCNA, CCNP and the combo CCNA, CCNP and SD-WAN from 4th of November after Diwali, and we are providing some discount as well. So if you are someone who is looking for any courses, networking courses, must visit pmnetworking.in, and if any course is suitable for you, then enroll yourself and let's meet in the live class, and after that we'll discuss these all protocol in detail, in very detail. Now the last thing is, if you have learned something from this video, then please hit on like button. If you have not subscribed this channel till now, if you are new on the channel, please subscribe this channel. We'll meet soon in the next video. Till then, stay safe. Bye bye. That's all for today.